unsupervised learning within the clustering. One other prominent technique is hierarchical clustering. So hierarchical clustering is widely used in natural language processing and text mining. It is also used on numerical data, but it got its prominence mostly from natural language processing, and it groups data into a hierarchy of clusters in the form of a tree. So dendrogram is the output. A tree-like model, which is a hierarchical or groups of data into hierarchical clusters in a tree form. We call it as dendrogram. Distance methods are similar to, so this is called dendrogram. So these are the clusters. This is a tree-shaped diagram, which is the output of the clustering process. This one is called the dendrogram. K-means will cluster it like this, but hierarchical cluster will do clustering in the form of a tree-based model called dendrogram. Another thing you need to understand in hierarchical clustering is the linkages. The linkages between the clusters. First one is single linkage, which is the minimum distance between the closest points of the cluster. Complete linkage, which is the maximum distance between the observations of the clusters. Average linkage will take the average of all the. Then we have the centroid method. Then the Watts method based on cluster variance. This Watts method is the method which is used in natural language processing and text mining. So linkages, or how you calculate the distance between the clusters. So in hierarchical clustering, the default is single linkage. Single linkage, wherein we'll take the minimum of the linkages, how you link the clusters. Then two approaches are used. The first one is agglomerative, bottom-up approach by taking all data points as a single cluster and merging them. One cluster is left. The second method which is used is divisive method, which is a top-down approach which starts by taking all data points as a single cluster and merging them till one cluster is left. Now let us understand this concept with the calculation. All of you can open an Excel sheet. Let us say we have, and the distances are 0.0, 0.5.6, 3.61, 4.24, 3.20, 4.95, 2.92, 3.54, 2.50, 2.24, 1.41, 2.50, B is 0, 0.50, E is 0, 1.12, F is 0. So this is the matrix of Euclidean distance. We have calculated for different points. So we had some data and we have calculated the Euclidean distance between the points, and this is the Euclidean distance. So this is an Euclidean distance matrix. So the Euclidean distance between A and B is 0.71. Between A and C is 5.66. A and D is 3.61. A and E is 4.24. A and F is 3.2. Between B and C is 4.95. B and A is 0.71. You already have the distance. Now, what is the closest distance or smallest distance? Iteration 1. What is the closest distance? 5, which is between D and cluster D and cluster F. The distance is 0.50, which is the minimum of all the distances in the matrix. The lowest, smallest distance is 0.5 between D and F. So we will merge cluster D and F like this. A. Now it will be D, comma F. Similarly, A, comma F. So we have merged, the first cluster merging happened between D and F because that is the lowest distance. That is the smallest distance. If you look at the other distances will remain same. There will be no change. So let us fill other distances first, leaving the newly formed cluster distances. C to C is 0. Then 1 point B2F to D2F is 0. We have to find the distance, and this will be 0. These are the original distances which will not get affected. Okay, I have filled the matrix with the distances which are not affected. Okay, they remain the same. Distance between A and B remains the same. Distance between A and C remains the same. But the distance between A and DF will change. So I left it blank. We'll calculate it. Similarly, distance between A and E remains same. Okay. So the empty spaces which you see here are the ones which we need to calculate. So we need to calculate these 3 cells and this cell. Rest of all remains the Because they're unaffected, right? We have merged only D and F. Rest of the points stay as it is. Now we need to find the distance between A and F. Distance between D comma F, distance between D comma F to A, right? We have to find the distance between DF and A, this cell. How will you find min of? We are using single, right? Single distance is D and A, distance of D and B. That means min of. What is the distance between D and A? 3.61. What is the distance between D and B? Not D and B, sorry, F and A. Sorry, we are finding between F and A. 3.20. So what is the lowest distance? Similarly, we need to find distance between DF to B, DB and FB. Distance between DB and FB. What is the distance between DB and FB? DB is 2.92, right? Similarly, we also have to find DF2, distance between D and C. D and C is 2.24. 2.24. F and C is 2.50. Similarly, we have to find the distance between DF and distance between D is 4.24, right? D is how much? Yeah, D is, the other one is 1 point, minimum is 1. Now we will fill these values. This is 3.20, 2.5, this is 2.24. So we have the iteration 1 afterwards. We have merged D and F first, DF into one cluster. Now iteration 2 will start. Iteration 2 will start. Now for starting the iteration 2, we need to first look at the smallest distance in the cluster. After iteration 1, what is the smallest distance in the cluster? 0.71. That is, we have to merge cluster A, comma, we will merge cluster A, comma B. C will be remain same. D and F is already merged, and E. Similarly, A, comma B, D, comma F, A to B is 0, C to C is 0, DF to DF is 0. Between to the points is 0. So DF to C is unaffected, 2.24, and 1 point. DF to E is also unaffected, which is 1. So we have to calculate what distances? We have to calculate these 3 distances, right? We have to calculate these 3 distances only. We have to calculate only these 3 distances because the rest of the distances remain unchanged. So let us first calculate AB2, which is min of.
In iteration 1, F2E maximum value 1.12. You taking 2.12. F2 D to F. Yeah, there, sir. Yes, sir.
So min of CA is how much? 5.66. Distance between C and A is how much? C and B is 4.95. 5.66, comma 4.95. What is the minimum? Then we have to calculate the distance between DDF to distance between AB. Now this will be min of distance of DA, D comma B, FA, FB. DA is how much? 3.61. DB is 2.92. FA is 3.20. FA is 2.50. So minimum of all this, the last one is AB to E, mean distance of 4.24, comma 3.54. This will be 3.54. So the values to be filled here is 4.95, 3.54. But నాకు salary slips లేవమ్మా, salary documents పంపించలేను. లేదమ్మా, మళ్ళీ మీ వాళ్ళు అబ్జెక్ట్ చేస్తారు కదా salary slips లేకపోతే. ఇంట్రెస్టెడ్ ఉన్నాను కానీ బట్ డాక్యుమెంటేషన్స్ లేకపోతే కుదరదు కదా. ఏమోనమ్మా, నాకు బజాజ్ నవంబర్లో అట్లాగే ఒకరు చెప్పేది అవుతుందని అవ్వలేదు. ఇదని కదా పిఎల్ అది చేయిస్తామన్నారు కానీ చేయించలేదు వాళ్ళు. బట్ ఐ హావ్ అదర్ లోన్స్ ఉన్నాయి. Now in this whole matrix, what is the lowest? 1 is the lowest between DF and E. So the matrix will change. Iteration 3, A comma B, B comma F as one cluster, A comma B. So in this case, AB to AB is 0, C to C is 0, DF to DFE is. Now AB to C, there will be no change, 4.95. C to DFE also no change. So we have to calculate only the distance of this cell, which is the distance between DF comma E to DF AB. min of D of DB, comma, D of EB. These distances we need, which is min of 3.61, 2.92, 2.50, 4.24, and 3.54. So the lowest value would be, so this value would be 2. Now, which is the smallest? AB remains the same. Now the smallest is comma F in brackets, comma E. This is 0. This is 0. DFEC2. So I'll go to the top. EAEB, distance between CA, distance between, comma, after 3.54, you have to add 5.66, 4.95. So the shortest distance is again, so this would be 2.50. So this is the final cluster formation which we are going to get. All right, all of you got this? Now, how the clusters will be linked? What was the first clusters we have combined? We have combined D and E, right? Sorry, D and F. We have combined first clusters D and, so we have drawn D and F as one cluster. Then we have added E to D and F. We have added a cluster called, value called E. This is DF2E. After that, what we did? We again added a cluster called C to the same thing, right? To the same thing, we have added a cluster called, and on top of this, we have another cluster A. This is called dendrogram. So this is how the dendrogram will create it. D and F first cluster, then we added E to the same, then we added C to the same. All the while A and B is one single tree-shaped diagram. We call it as dendrogram. The output will be a dendrogram like this. We went from bottom to up. So hierarchical clustering analysis also based on distance metrics, but it's a different type of grouping. Minimum distance, again, distance-wise metrics only, but here the output will be a dendrogram, which will be a tree-shaped model, and it will give us the cluster. So there are two clusters. This whole thing is one cluster. A and B is in one cluster. How many clusters it formed? 2. A and B as one cluster, and this DFEC in 1. So total clusters formed is 2. So this is the methodology used in hierarchical clustering based on the Euclidean distance method. In Vidyanagar, Masjid Lane left side 5th apartment, Sai Mohan enclave. But in intlo lane, my parents untaru. So this is the process of hierarchical clustering, also called as agglomerative clustering, because default is agglomerative method. We call it as agglomerative clustering also. And the linkage is single. We are taking the minimum distance from the observation. If you take complete, it will take the maximum distance, and then it starts grouping. So this is the process of hierarchical clustering. Dot cluster agglomerative clustering. H underscore clust is equal to agglomerative clustering n underscore clusters. Right? Affinity is equal to Euclidean is equal to what? H underscore clust underscore model is equal to H underscore clust dot fit. What is the data frame name? So these are the labels for the different observations. So these are the cluster labels for each observations we will assign. If you want to see the dendrogram, sci-fi dot cluster dot hierarchy for import as SCH is equal to SCH dot linkage, but you will get the dendrogram like this. You can see here 17, 11 and 19 and 7 are in one cluster. 1, 3, 5, 13. This is completely one cluster. This is one cluster. So we have total 5 clusters which we have given. So how many clusters we have used for k-means? 5 only, no? No, we have used 5 only, I think.
We need 6th one, sir.
Yeah, but 6th one was overlapping, so 5 we took, I think. Here also taken 5.
Okay, sir. Okay, sir.
Here also we have taken 5. All right, all of you got the clustering, hierarchical clustering. 1, 2, 3. No, we got only 3 clusters here. P parameter for truncate mode, color threshold, orientation. I think it has taken the best value on its own. We have not specified the clusters. So orange is one cluster, green is one cluster, red is one cluster. 3 clusters it has formed. By default, it has formed on its own 3 clusters. Or we have to give, I think, Euclidean distance matrix. X underscore Euclid dist is equal to Euclidean distances of Now we have the distance matrix. Clusters, orange, green, red, and because we have not given any no option of giving. There is no option of giving the number of clusters here, right? So we don't have the option. Z is the linkage matrix or the Euclidean distance matrix. So using the Euclidean distance, we can get the matrix like this. Now, in both k-means clustering and hierarchical clustering, one of the biggest challenges is to decide the number of clusters. We have to give n clusters. How many clusters we want, we have to give. And there are different methods. Elbow method, Silhouette score. In hierarchical clustering, dendrogram will help you to identify the clusters. There is a clustering method called density-based that clusters by separating high density regions to low density regions. High density regions to low density regions. DB-scan does not require the specification of the number of clusters. DB-scan by default uses Euclidean distance. DB-scan is, now DB-scan requires two parameters. DB-scan requires two parameters to be specified. The first one is, which is the least distance for 2 points to be termed as. The second is min points, number of points to construct a cluster. A cluster is recognized only if greater than or equal to. Now, there are three types of data points. The first one is core, point from which two parameters are fully defined. Any data point that is not core less than minimum points. So, min points is 3. So, each cluster should have minimum of 3 points. And in between, there will be a core point. It's like a centroid. And border point is the point nearest to the border. Noise are those points where you can't find the minimum points. Outliers. Noises are nothing but outliers. So this is the structure of a DB-scan algorithm. Border point and noise point. DB-scan algorithm. So based on the minimum points, the cluster will be created. Two parameters we need to give. One is epsilon. The second is minimum points. If the data set has more than 2 dimensions per cluster, min points is equal to 2 into data dimension. The formula for defining the min points is 2 into data dimension. To calculate epsilon algorithm, to identify the epsilon, nearest neighbors algorithm is used. From sklearn dot neighbors, nearest neighbors, neighbor is equal to nearest neighbors n underscore neighbors is equal to 5. NBRS is equal to distances, comma, is equal to NBRS dot distances is equal to NP dot sort colon comma 1 square bracket. So we are trying to find the epsilon here using the nearest neighbors method. DB-scan is a very advanced clustering used in very large scale data developed by Google guys. K-means and hierarchical are very easy. DB-scan is a little bit complicated. So plt.plot. So once you plot the distances, you need to see where it is flattening. It is flattening somewhere around 15. See here, the straight line is increasing somewhere around 15. Or let us say plt.0 comma. So somewhere after 15, it is becoming a, you can see, right, 15. Bigger is here, 4. But if you see the point, epsilon is going upwards, right? 15 is also a point where it is going upwards. Or let us see, epsilon. Oh, you have to look at the cluster distance, not the cluster pair. Or let us see, point of maximum curvature. Point of maximum curvature. So point of maximum curvature we have to look for. The maximum curvature is somewhere around here only, 4 to 5, 175. Huh? But we have very less data. Huh? Let's go with epsilon of 15. Let us take this point as the maximum curvature. Epsilon as 15. Min points is 5. From sklearn dot cluster db scan. dbs is equal to db scan. EPS is equal to 15. Min underscore samples is equal to 5. dot fit TLT dot scatter. Oh, we have two blues going out of shade here. Actually, we have to give X 100 and you have to see on the left where the maximum curvature is happening. So don't give the limit. What happens? Now you can see here. See, the maximum curvature is happening at somewhere below 15. See, the maximum curvature is happening below 15, right? So shall we take 14? Epsilon as 14. Did we get any overlaps? Still, we have three blues overlapping with red. Blues are increasing, oranges are also increasing. So we have to increase the epsilon to 17. So nothing. I think epsilon 15 is better. It is giving some sort of cluster formation. There are no clusters. As I increase the number, it is becoming one cluster or two clusters. We need to have grouping of clusters in distinct manner. Very well separated with minimum overlapping. So smaller data is affecting here. See, DBScan is exclusively designed with mind of working with large scale data set. Google has developed it for its own data set. So when you are dealing with lakhs of rows of data, DBScan is a very perfect algorithm. See, when you have a distinct or clear centroids, k-means work. When centroids overlap or when you can't create proper centroids, then you have to go with. See, DBScan is used when k-means is not able to cluster your data. Then the second option we go is with DBScan. You don't have to give the number of clusters. So that is another advantage. You don't need to specify the number of clusters. See, unsupervised, when you're in IoT data we see, Internet of Things, when sensors fail, particularly some sensors fail, the data gets corrupted. The collection process of the data will get corrupted. So there it becomes completely unsupervised data. When data is collected through sensors and there is a malfunction in sensors, some of the sensors, your data goes completely get corrupted and it becomes an unsupervised. So you have to clean the data and then do it. So that is the instance where we can see unsupervised data coming in. Otherwise, most of it will be supervised data. K-means. K-means are hierarchical based on the data you're dealing with. We use both k-means as well as hierarchical clustering. Yeah, supervised. Clustering is both supervised as well as unsupervised. See, segmentations, when you want to group your customers. So these are the clustering methods. Third floor reception में दे दो. Telecom नगर bus stop का बगल वाला building है. Bus stop बगल वाला building है. ఎక్కడున్నా मैं ప్రస్తుతం ఇంకా ముందుకు రా ఇంకా ముందుకు వస్తే ఫ్లైఓవర్ ఎక్కకుండా లెఫ్ట్ సైడ్ కి వస్తే బస్ స్టాప్ ఉంటుంది టెలికాం నగర్ పుష్పక్ బస్ స్టాప్ ఆ బస్ స్టాప్ పక్క బిల్డింగ్ ఫ్లైఓవర్ ఎక్కకుండా కిందకి వస్తే ప్రకాష్ లైట్స్ బిల్డింగ్ ఉంటుంది దాని పక్క బిల్డింగ్ దాని పక్క బిల్డింగ్ కేఫ్ ఎక్కలాట్ అని ఉంటుంది ట్రెండ్స్ ద్వారకా అదే బిల్డింగ్ అదే ట్రెండ్స్ ద్వారకా థర్డ్ ఫ్లోర్